Okay, welcome back. And so this is our last WebEx meeting. So just a little reminder, we got a couple things due, or we got the oligopoly homework, which we went over last week, and that's due today. So make sure you post that on Blackboard sometime today, or let me know if you have any questions on that. And so I think everyone's got a topic and everything ready to go there. And so the only thing really we have left, once you turn in that last assignment, the oligopoly homework, is we have the take-home final exam, which we're going to discuss today. So what I have planned today is kind of go through some practice problems, do a little review session for the final exam, and take any questions, and that'll kind of be it. So just yeah. So any questions on the oligopoly homework that's due today? Just before we get started, everyone good on that? Getting that in today? Okay. Okay, then we'll get right into the details for the final. Also, and just I'll remind you, and it says on the exam, but the final exam is going to be due this Thursday, like it said in the syllabus. And so it's going to be due via email, just like the midterm. And so make sure you send me your exam. It shouldn't take too long, but make sure you send it to me by Thursday. And then if everything goes to plan and I get all those exams, I should have your grades done and available by Friday. And so please try to get me those exams and everything by Thursday, and I should be able to get them graded, and I'll have your grades and everything up, and all the classes or all the grading done by Friday, assuming everything goes to plan. So due date for the final by email is this Thursday. All right. So I have a whole practice exam we're going to go through as kind of a review session. All right, and then your final exam is right here. It's going to be due via email. We'll get to that after we go through the practice problems. So this is kind of what your exam is going to look like. I'll open up. If you go to final exam, summer 2021, and here's the exam in PDF and Word document form and the solutions. Okay, so we'll go through this one in a second, but you're going to have three questions. One, and basically like one on chapter 8, one on chapter 9, and one on chapter 10. So one on all the profit maximizing stuff and choosing different markets. So we'll go through that one. This will be like your chapter 8 homework. Number 2 will be on the oligopoly and the Cournot and Stackelberg. So this will be like your chapter 9 homework. And number 3, another big one on game theory. So you have a one-time game, uncertain final period, and then a multi-stage or game tree sequential game. And so this will be familiar with your chapter 10 homework. So very similar, if you did all the homework assignments, very similar to the homework assignments you did for each of those chapters post midterm. Okay, so again, assuming you've been coming to class and doing the homework, shouldn't be all of this material should be familiar, but I'll make sure you got it for the final. And so let's go ahead and go through this practice exam. And yeah, that's what we'll do here. Okay, so I'll go ahead and pull up the practice exam final summer 2021 solutions. Um, Excel file. Okay, that's the Excel work, but I can pull up this one here. Okay, so let's go through this one, and here's the practice exam. Going to be very similar to the one you're going to do. Let's do this week, your take-home final. So question number one is going to be three different types of profit maximizing models, and then you'll choose at the end which model it is based on the clues. So number one is the following equation describes a firm's total costs, right? So the total cost is 5 plus Q squared. Okay, and so if the firm is a price taker and other firms in the industry sell output at a price of $9, what price should the manager of this firm put on the product? So you know the keyword there is price taker. All right, if it's price taker, that should signal that you're in a perfect competition scenario. And if the price is set at $9, right, if there's a price taker firm and other firms sell at $9, that's the price that consumers have determined they're going to pay for this product now. And so simply, you don't have to do any math here. The firm is going to charge $9. So price taker, what do the other firms sell at? This firm sells at that price. Um, right? That's what they do. So price for this price taking firm is going to be set at $9. Okay. B, what level of output should be produced to maximize profits or minimize losses? Okay, so we know that the best quantity is always the profit maximizing choice where MR equals MC. Okay, so we got to find, oh, and also we know in perfect competition with the price taker that MR equals the price. So we can instead, since we know this is equal to price, we can just sub that in. And now price equal to marginal cost will be our condition only for perfect competition. So we got the price from $9. What's the marginal cost? We need to find that. So total cost is given, 5 plus Q squared, right? And marginal cost, differentiate that with respect to Q, and that would just be 1 plus 2Q, right? So um, set marginal cost equal to price, and let's find Q. So price is 9. We determine marginal cost 1 plus 2Q. Set those equal. Here we go. And let's go ahead and just do a little algebra, rearrange, and solve for Q. So subtract 1 from both sides, and we'll get 2Q equals 8, and let's divide by 2. Okay, and we know that Q star is 4 units. Okay, so this price-taking perfect competition firm selling at a price of $9 is going to its best case is to sell 4 units, and that's what it'll do. Okay, should the firm keep producing or shut down? So you want to find the situation in which the price of the firm is charging, in this case $9, is that greater than, equal to, or less than um, the average variable cost at the optimal Q. Okay, so this, looking at some of your homeworks, this is probably the biggest area of problem, I would say, in that determining this identity. So make sure that you're doing the average variable cost part correctly, because I think this is the part where most students miss the most on their homework, is just getting the average variable cost correctly. So what you want to do is get the general equation for the average variable cost and then put in Q star. So just to get the average variable cost, first of all, look at the total cost. All right. And variable cost is only the portion that is affected by Q. So this 5 here, if there's just a number, that doesn't vary with the quantity. That's a fixed cost. So if there's just a number that's not attached to a Q, that's not part of the variable cost. The variable cost is only the part with the Q's. So Q plus Q squared is the variable cost. Average variable cost is this variable cost and average. So if you divide this by Q, what do you get? Q divided by Q is 1, plus Q squared divided by Q is Q. So you get 1 plus Q. Okay, so make sure that you see what's going on here with the average variable cost. It's kind of two steps. And maybe I didn't explain it clearly in the first time, but we'll go through a few of these. But what you want to do is pick out the variable cost portion, which is only the part of the total cost with the Q's, and then divide by Q. So this part divided by Q is just 1 plus Q, right? Okay. Now, you know what the average variable cost is. What is the average variable cost at this Q of 4? That's easy. Just put in the 4 units. So is the price of 9 bigger than 1 plus Q star? 9 is bigger than 1 plus 4, which is our Q. And 9 is bigger than 1 plus 5, so the firm is going to go ahead and keep producing because the price gives them enough revenue to coverage the average variable costs, which would mean that shutting down would cost them a bigger loss. So even if they don't make a profit, it's better that the price is high enough to cover their variable cost portion, and they're going to go ahead and keep producing. All right. And the rest of it, most of you got, but let's calculate profit or losses. So profit or losses is always revenue minus cost, total revenue minus total cost. Total revenue is the price of this good 9 times the Q of 4 and minus the cost function. And remember the cost function is given right there. Okay, so price times quantity minus the cost function. And so we get 9 times 4 minus 5 minus Q of 4 minus 4 squared. So make sure you subtract all these costs because this is the fixed cost. This is one portion of the variable cost, is the other portion, but all these need to be subtracted because these are costs. So this is revenue, this is cost. The costs get taken away and the revenue gets added. So we get 9 times 4 minus 5 minus 4 minus 4 squared, which is 36 minus 5 minus 4 minus 4 squared, 16. And if you put all that together, this firm makes $11. Okay, so this firm sells kale, which is a perfect substitute at a farmer's market. So you see, you already know what type of firm this is, but there's clear clues. Perfect substitute, farmer's market. We know what this is. This is a perfect competition firm because perfect substitution and agricultural goods that I always reference at farmers markets indicate examples of this type of market. So what type of market is this? You know that. It's perfect competition. Okay, part F, G, H, and I is the second portion for a different type of market. So that each of these is going to be for identifying a different market, and you have 4 choices. And so it's probably one. Each of these will be one of those 4 types. And we've already got perfect competition, so that one's probably not going to be um, chosen again. And the second portion is the following equations describe a firm's demand and total cost. So here's the demand curve. Here's the total cost curve. And remember, every time you see the total cost, just kind of notice the parts that are fixed and the parts that are variable. So when we calculate our revenue and our marginal cost, we need the whole thing. But when we calculate variable cost, this is not a variable cost because it doesn't depend on Q. So that 1,000 is a fixed cost. When we're looking at variable costs in part H, only look at this portion. Okay, so only the parts of the total cost that have Q's are variable cost. The rest of it is a fixed cost. All right, what level of output should the firm produce to maximize profits or minimize losses? Okay, so we are going to, again, we know we're solving for MR equals MC. We need to find MR and we need to find MC. So total revenue first, and then we'll get marginal revenue based on the total revenue after that. So total revenue is price times quantity. This is price. Multiply that by Q. 61 minus 2Q times Q. Okay, just distribute the Q and we get total revenue is 61Q minus 2Q squared. Now, if you differentiate this with respect to Q, you'd get 61 minus 4Q, right? So that's our marginal revenue. And let's get our marginal cost based on the total cost of given 1,000 plus Q squared. If you differentiate that with respect to Q, you would get 1 plus 2Q. Okay, so to find the best Q, set that equal to that. And that's exactly what we've done here. 61 minus 4Q equals 1 plus 2Q. And let's rearrange, add 4Q to both sides and subtract 1, and we get 6Q equals 60. Let's go ahead and divide by 6, and we get 60 divided by 6, and Q star is 10. Okay, and this time the price isn't given, so if we get the choice, we'd like to choose our price based on what the demand curve looks like. So if we want to sell 10 units, let's find out what, on average, the market would pay for 10 units of this good or service. So just plug in the 10 into the demand curve right there. So we start with the demand curve. 61 minus 2Q, that's given. Plug in Q of 10, and we get 61 minus 2 times 10, 61 minus 20, and the price we'll charge for this good is $41. All right. Should the firm keep producing or shut down? So again, you want to find the see if this identity holds. Either way, you got the price already. You got to calculate average variable cost at Q star 10. But first, what's average variable cost? Look at the total cost curve. What's the portion that only has Q's? Q plus Q squared. Okay, that's the variable cost. Now, the average variable cost is the variable cost on average. So on average, divide by Q. So if we divide this little section by Q, we get Q divided by Q is 1, plus Q squared divided by Q is Q. So 1, divide this by Q, right? Just 1 plus Q. So is the price 41 bigger than or equal to 1 plus 10? It is. So 41, this price covers the average variable cost, which is $11 on average per unit. So this should make total sense because the goods we're selling give us $41. It's only costing us $11 per unit. So we're clearly getting more by selling than not selling. So the firm should keep producing because price at this Q is bigger than or equal to average variable cost. And then let's calculate profit or losses in the same manner. So profit or losses is always revenue minus cost. Revenue is 41 price times Q, 10, price times quantity, 41 times 10, minus the cost function, which is given 1,000 plus Q squared. All right, price times quantity minus 1,000, minus Q of 10, minus Q squared, 10 squared. And if we do this, solve it out, we get 410 minus 1,000, minus 10, minus 100, and that comes out to profit star, which it technically is a loss, is negative 700. So this firm is minimizing losses at 700. And you should always check if you determine the firm should keep producing and you get a loss, make sure that that loss is bigger than shutting down. So if we produce, we lose 700. If we shut down, we lose the fixed cost of 1,000. Now, it's not the best scenario, but losing 700 is better than losing 1,000. So always compare when you get a loss. If you're going to keep producing, make sure that makes sense, that it's bigger than your fixed cost that you would lose if you shut down. So if we shut down, we lose 1,000. If we keep producing, we lose 700. Losing 700 is better than losing 1,000, so we're going to keep producing and minimize our losses. And what type of firm is this? So the firm sells razors and competes with other firms selling slightly differentiated razors. You should see the keyword there, slightly differentiated, and you know that you should probably also know that the razor market can only be monopolistic competition or oligopoly. And I think there's a whole lot of different firms, not a lot of high-level firms or tech firms selling razors. You get lots of knockoffs and lots of different. If you go to Target or Costco or any grocery store or a drugstore, you'll see that there's brand names, there's bulk discounts, there's generics, and uh, there's way too many options for razors based on what the razor is. So it's different brands, different features, disposable, better quality ones where you keep the portion and just switch out the top part. There's some that are like battery powered or lubricated, whatever, but lots of different types of options for razors, and that really defines a market in which it's monopolistic competition because you have lots of firms competing to sell this in this razor market. Slightly different. Oh, let me let someone in here. Okay, and so all those little clues there should signal that this firm is in monopolistic competition. And you can probably see that it's hard to. So this firm would be selling like, think of this as like $41 seems like a lot, but that's probably like a pack of razors. And this, if you go to like Costco or Target, you can probably buy like a bulk pack of razors for like $41 or something like that. So that it's the point is that it's hard to make money in this type of market because there's all types of different firms trying to compete in this razor market. So yeah, monopolistic competition for this firm. Okay, the last section here is the final type of market, parts K, L, M, and N, and O. So one more of these, and that'll finish number one. So we've chosen already perfect competition and monopolistic competition. So this one would probably be oligopoly or monopoly. So the following equation describes a firm's. The following equation describes a firm's demand and total costs, where here's the demand curve and here's the total cost. And again, the fixed cost is different, but the variable cost is the same. So the part with the q's is still q plus q squared, and the fixed cost is only 5. Okay. What level of output should be produced to maximize profits or minimize losses? So we want to find where MR equals MC, and we need to find first total revenue in MR, and then MC based on the total cost. So total revenue is price times quantity. This is price, multiply that by Q. 101 minus Q times Q, distribute the Q, and total revenue is 101 Q minus Q squared. If you differentiate that with respect to Q, you'd get 101 minus 2Q. And total cost is given, 5 plus q squared, and if you differentiate that with respect to q, you'd get 1 plus 2q. And let's set this equal to this, MR equals MC, and solve for the best q for this firm. Okay, so MR equals MC, 101 minus 2q equals 1 plus 2q. And let's go ahead and just solve for q here. So add 2q to both sides and subtract 1, and we get 4q equals 100. If you divide both sides by 4, you'd get 100 divided by 4, and the optimal q, the best thing the firm could do, is sell 25 units. Okay, what is the market price? Just go ahead and put the best quantity into the demand curve right there. Put the q of 25 right there. So demand curve is given 101 minus q, plug in q of 25, and we get 101 minus 25. This firm should charge $76 per unit. Okay, should the firm keep producing or shut down? So again, you know the condition, and just to do one more time of how you get the average variable cost. You want to look at the total cost and isolate only the parts that have Q's right there, where this is not a variable cost, the 5, that's a fixed cost. So the only variable cost is Q plus Q squared, and the average variable cost is the variable cost, this part, divided by Q. So take this part divided by Q, and you get 1 plus Q. Okay, so is the price we determined of 76 bigger than 1 plus Q? 1 plus 25 is our Q, and so it is. We get at least $76 of revenue, and it only costs us 26 on the margin, so we're going to go ahead and keep producing. This condition holds. What's our revenue? What's our profit or loss? Revenue minus cost. Revenue is price, $76 times 25, and minus the cost function, given of 5 plus q squared. So price times quantity minus 5, minus 25, minus 25 squared, plugging in our q's of 25. And our profit, or, oops. Our profit or loss is 1900 minus 5 minus 25 minus 25 squared, which is 625. And you do put all this in a calculator, or just do the math, and you get profit now positive of 1,245. And this firm, this is a public firm which picks up trash and recycling. No other businesses offer this service in the city. What type of market is this firm operating in? So a couple clues there. It's, well, this would classify as a public utility, so public firm which picks up trash or does a water service or does electricity or gas. That product that denotes it is a public utility, essentially. And also, the main thing is no other businesses offer this service in the city. So that means they're the only firm in which customers can pay for their trash to be picked up. So there's no other firms that do this. That automatically means if there's just one firm doing it, it's a monopoly. So this type of firm operates a monopoly, and that's probably why they're charging, a pretty high price of $76 probably monthly to pick up trash. Okay, so there's your example of part one. And again, I think just grading the homeworks and looking over them, the main issue or the main part where there were some errors, just double check, were part C's, where just make sure you calculate the average variable cost correctly, and that's the part where I make sure you double check it. So make sure you get this part right, and I think most students got the rest of it right. All right, so you got quite a few examples of that one. Any questions on this type of problem? All right, so number two, and so number two is going to be on the Cornell-Stackelberg. And so students did very well in this in the homework assignments. Normally this is I think this is a more difficult one, like if you take a in-class exam, but I think most students with the examples did very well on this one, so I don't expect there'll be a lot of problems on number two, but let me just go through another example that you have. So you got Cornell versus Stackelberg, chapter 9, and let's suppose the inverse demand function and the cost function for two duopolists, there's two of them, is given by the demand function with the two firms, and each firm has the same cost structure, where it's essentially 4 times Q. Okay, so we'll basically do it for Cornell. We'll do it for Stackelberg, and then we'll do a little summary. So assuming two Cornell duopolists, what is firm one's quantity and profit? What is firm two's quantity and profit? And what's the market price? You don't have to do it in the specific order, but I usually do it. I usually go through and find the reaction functions, and then the quantities of both firms, which should be the same under Cornell, and then I go ahead and find the price, and then when you get the price, you can get the profits. So you basically need the quantities first, the price second, and then you can get the profits last. And for this type of market, Cornell, you should come out with each firm's kind of splitting the market, so they should have the same quantities and the same profits if you did this one correctly. So first, here's the demand function. Okay, so we'll use that 44 minus Q, 44 minus Q1 minus Q2 to get the revenue functions. Okay, so this one, if you simplify it, is just 44 minus Q1 minus Q2, which is price. And we're going to put that price here for firm one's revenue and also over here for firm two's revenue. So for firm one, it's the price. Here's the demand function times its quantity, Q1. And over here, it's the price, the demand function times its quantity, Q2. And if we kind of go through these the same time, just distribute the Q1 and Q2s, we'd get for firm 1, revenue of firm 1 is 44Q1 minus Q1 squared minus Q2Q1. And the revenue function of firm 2 is 44Q2 minus Q2 squared minus Q1Q2. Then if you go ahead and differentiate each, this one with respect to Q1, you get 44 minus 2Q1 minus Q2. And if you differentiate this R2 with respect to Q2, you'd get 44 minus 2Q2 minus Q1. Okay, and then the optimal solution, i.e. reaction function, is when each firm's marginal revenue equals their marginal cost. So we want, for firm 1, MR1 equals MC1, and for firm 2, MR2 equals MC2. MR1, we got that up there, 44 minus 2Q1 minus Q2, and marginal cost for all firms, here's firm 1, so if you differentiate this with respect to Q1, it's 4. Or if you differentiate this with respect to Q2, it's also 4. So both firms have a marginal cost of 4. Okay, so there's MR equals MC for firm 1, and there's MR equals MC for firm 2. Here, let's solve for Q1, and here, let's solve for Q2. So if you, what are we doing here? Let's subtract 4 from both sides and add Q2 to both sides? No. Let's sorry. Let's add 2Q1 to both sides and let's subtract 4 to both sides. So we'll get 2Q1 equals 40 minus Q squared. And over here, let's do the same thing. Let's add 2Q2 to both sides and subtract 4 from both sides. We'll get 2Q2 equals 40 minus Q1. And if we divide by 2, we just get Q1. is 20 minus 1 half Q2, and if we divide over here for firm 2 by 2, Q2 equals 20 minus 1 half Q1. So we get a reciprocal reaction functions for firm 1, 20 minus 1 half Q2, and for firm 2, 20 minus 1 half Q1. Okay, so now to get the optimal Qs, you can go either way, but let's go ahead and plug this reaction function, Q2 equals 20 minus 1 half Q1, into firm 1's reaction function. So this goes in there. All right, and then, well, I guess we can do it both ways at the same time. And then this will go in here. So we get 20 minus 1 half times 20 minus 1 half Q1. That's Q2. Firm 2's reaction function, or we get Q2 equals 20 minus 1 half, plug in firm 1's reaction function, 20 minus 1 half Q2. And we get 20 minus 10 minus plus 1/4 Q1, and we get Q2 equals 20 minus 1 half plus 1/4 Q2. Over here, let's subtract 1/4 Q1 from both sides, so we get 3/4 Q1 equals 10. Same thing over here. 3/4 Q2 equals 10. Multiply both sides by 4/3, and we get 4/3 times 10. Same thing, 4/3 times 10. Q2 equals 40 over 3, which is roughly 13. And we get the same outcome for firm 2, where Q2 star is also 40 over 3, which is roughly 13. Okay, now let's put the Q1 and the Q2 into the demand curve and find the price of this good or service. There's our demand curve given. Let's plug in 13 there and 13 there. We get price is roughly 44 minus 40/3 minus 40/3. And that comes out to roughly 52/3. Or let's simplify, that's roughly 17. Okay. And firm 1's profit is price times its quantity minus its cost structure. And firm 2's profit is the same way. So plug in the price of 52/3 times the quantity of 40/3 minus 4. This is the cost function for firm 1, and this is the cost function of firm 2, so just plug in their Q's. Okay, so price times quantity minus 40 times 40/3, and same thing over here. 52/3 price times Q2 star 40/3 minus 4 times 40/3. And if we do the math, we get roughly firm 1 makes a profit in Corno of 178. Firm 2 makes a profit under Corno of 178. So they both produce roughly 13. Price of this good or service in the market is 17. And they both make about $178. Okay, selling roughly 13 units. Okay, and then let's go ahead and do the analysis with Stackelberg and run some comparisons and summaries. So we know that we have the same demand curve and cost structures, but now we have a leader, firm 1, and a follower, firm 2, because in the Stackelberg scenario, there's one firm that's a little bit bigger, gets to go first, and one firm that gets to go second because they're not as big. So firm 1's going to set its output first. Firm 2 is going to take firm 1's output is given and set its output second. So there's a first mover here where firm 1 goes first and firm 2 goes second. Given that, we could do the analysis again, but we know that if we did the MR equals MC, we'd get the same reaction function of firm 2, which would be this, 20 minus 1 half Q1. So we've already found that. That's firm 2's reaction function. And we know that firm 1's revenue is the same we got here, which is this, 44 Q1 minus Q1 squared minus Q2 Q1. Okay, so you could double check these, but you know they're going to be the same because the demand curve and the cost structure is the same as before. So firm two's reaction function, we've already found that, and firm one's revenue, we've already found that. So we can just start with those, state them, and we don't need to solve for those again because we've already done that. Okay. Firm one's going first. So let's find firm one's profit and internalize firm two's reaction function into firm one's profit. So firm one's profit is this revenue, this minus its costs, and that's given 4Q1, right? There it is. All right, so revenue minus cost. If we simplify, we get 44Q1 minus 4Q1 is 40Q1 minus Q1 squared minus Q2 Q1. Now we're going to go ahead and plug in firm two's reaction function into this Q2, yeah? So we get profit of firm one is 40Q1 minus Q1 squared minus Q1 and Q2. Plug in this. Okay, and we get 40Q1 minus Q1 squared minus 20Q1 plus 1/2 Q1 squared. If we're getting close to simplifying, uh, 40Q1 minus 20Q1 is 20Q1, and then 1 minus Q1 squared plus 1/2 Q1 squared simplifies nicely to 1/2 Q1 squared. So we're left with profit of firm 1 is 20 minus Q1, sorry, profit of firm 1 is 20Q1 minus 1/2 Q1 squared. That's it. Now, all we have to do for firm 1 is maximize this revenue function, I'm sorry, this profit function by choosing the best Q1. Okay, so let's maximize profit, which is 20Q1 minus 1/2 Q1 squared. And to do that, differentiate this and set it equal to 0 because that's the point, that's the Q1 in which the profit function maxes out and can't go any higher. So below that, you can get more revenue. Beyond that, you're losing revenue. So we want exactly when this slope is at 0 because that's the high point of the profit function. Okay, so differentiate this and then set it equal to 0. So if you differentiate this with respect to Q1, you get 20 minus 2 times 1/2 is 1. So 20 minus Q1. And again, when this derivative equals 0, that's when profit is maximized. So when is 20 minus Q1 equals 0? That's pretty easy to find. You can just take this condition, put Q1 over there, and this confirms when Q1 equals 20. Okay, so profit is maximized for firm 1 when they choose an output of 20. Okay, so we got firm 1's best quantity. Now firm 2 gets to react, so firm 2 is going to take Q1 squared as given and put it into their reaction function. So this Q1 squared is going to go right into there. So firm 2's reaction function, we know what that is, 20 minus 1/2 Q1. And now we know what Q1 is. It's the leader. They chose 20. So the follower is going to go ahead and go 20 minus 1/2 20. And their best case is 20 minus 10, which is a Q2 star. For firm 2, their best case is 10. So the best they can do is half of what firm 1 has done. And what's the market price of this good or service? Plug in Q1 star and Q2 star that we found into the demand function here. Okay, plug in those values we found. So this is given 44 minus 1/2, sorry, 44 minus Q1 minus Q2. And we get 44 minus Q1 is 20, Q2 is 10, and we get a market price of $14. Okay, so you found firm 1's quantity, profit, and he found that in both cases, Cornell versus Stackelberg, and he also found the market price in the two different markets. Oh, sorry, we got to find firm one's profit and firm two's profit under Stackelberg. So firm one's profit is price times quantity minus cost, and we found price 14. We know they'll choose 20, and the cost structure for all the firms is 4 times 20. So this minus that, profit of firm one is 200. The same for firm two. They're going to charge, they're going to make price times how much they sell minus their cost function. Price we determined was 14. Firm two, the follower is going to sell 10 units, and the cost structure is 4 times 10. So this comes out to 100. So firm one under Stackelberg makes 200. Firm two under Stackelberg makes 100. Then which of the four firms makes the highest profit and also the lowest profit? So the highest profit, so we got 200, 100, 178, and 178. So of all the four, firm one Stackelberg leader makes the highest profit. And of all the four firms, firm two Stackelberg follower makes the lowest profit. All right, that's how it should come out. And then also the lowest market price, you can compare them, is Stackelberg 14 versus Cornell 17. So Stackelberg is a little bit lower, which means that Stackelberg market has the lowest price. So that should be what you get. And usually you'll see if there's a bigger firm that dominates the market, they're able to get a little bit more profit, not by selling a higher price, but just by getting more of the market. So even though you might think that, the equally splitting the market would give the customers the best price, not really the case, because this firm's, the leaders in the Stackelberg situation, really gets the most profit by just selling the most and dominating a higher proportion of the market. All right, so again, I think most students did this pretty much correctly on the homework. But any questions on the Cornell-Stackelberg type? Okay. Number 3 will be on a game theory situation. So you're going to get a little word problem. You'll do the one-time game. You'll do an uncertain final period. And then you'll have an extended or sequential game where you draw the game tree for a different example. So here's this example you can use. Question type number 3, game theory. Let's assume it's 1985 and Nintendo and Atari play the following simultaneous move game. Nintendo has 2 pricing options for its Nintendo Entertainment System, and Atari has 2 pricing options for its new game console. Both Nintendo and Atari can either price their new game consoles at $100 or $200. So you see the trade-off here. The competition is trying to either undercut the other firm, or both agree to charge a high price and both kind of split the market with a higher price good or service. So if both firms price at 100, each firm earns profits of 1 million. If both price at 200, they earn more, 5 million each. And if one undercuts and prices at 100 and takes all the customers, okay, and one prices at 200, the company that prices at 100 gets 10 million because the customers would rather have a cheaper price good, and the company that prices at 200 loses $1 million. So that's not good for them. Okay. So go ahead and put Nintendo on the left side, and Nintendo's profits first, and Atari's profits listed second. So Nintendo's going to go on the left, Atari's going to go on the top, and we'll put Nintendo's payouts first, comma, Atari's payouts second. So this is what the word problem described. Nintendo has two choices, 200, 100. Atari has two choices, 200, 100 to price their game consoles. If they both price at 100, they both get a million. If they both price at 200, if they can make that agreement, they both get 5 million. But if one undercuts the other, the undercutter with the lower good gets most of the customers and they get 10 million, and the firm that prices higher loses a million. So that's a that's the game tree. And part B, just go ahead and define the Nash equilibrium. So the Nash equilibrium, remember, is if there's no agreement and both firms act in self-interest, what's the best choice given what the other firm would do? So if Atari prices at 100, Nintendo could price at 100 and get a million, or 200 and lose a million, they're going to price at 100. If Atari prices at 200, Nintendo could price at 100 and get 10 million, or price at 200 and get 5. So no matter what, without some agreement, it's in Nintendo's best interest to always price at 100 because that gives them the highest expected outcome. And because the game is symmetrical, it's going to be the same for Atari. So if Nintendo prices at 100, Atari could price at 100 and get 1, or price at 200 and lose 1. They're going to price at 100 and get the 1. If Nintendo prices at 200, Atari could price at 100 and get 10, or price at 200 and get 5. So it's in Atari's best interest to always price at 100 because that gives them the highest expected outcome. So you can see that without an agreement, both firms are always going to choose to price at 100, and just choosing their best responses, the outcome will be this one, where both firms price at 100, so price at 100, price at 100, both firms make a million. So uh, the Nash equilibrium, you could describe it as Nintendo prices at 100, Atari prices at 100, Nintendo receives a million, and Atari also receives a million. So this highlighted double underlined outcome can be described like this. Okay, so games with an uncertain final period. So now assume Nintendo and Atari play the following game repeatedly, so not just once, and there's an uncertain final period, and specifically there's a 5% chance of a union strike, which would end the game. So they're playing this game multiple times, but each time they play it, there's a 5% chance the game, the union strikes. And if that happens, no one gets to sell anything, the production shut down. So 5% chance during any game that it doesn't happen. All right, so given those chances, both agree to price their new game consoles at 200, provided neither company cheats on the agreement. So you can clearly see if they both can agree on this outcome and not cheat, um, in a vacuum, that's better for both firms because each time they play it, instead of getting a million, they both charge 200. The customers have no choice; they can buy from either firm, but they're both selling at 200, and they're both going to make 5 million per round. So is that agreement worth not having the temptation to cheat? So let's see. What is Nintendo's profit if it cheats, and what is Nintendo's profit if it cooperates, and what will Nintendo do? Which also means what will Atari do, because their choices are the same. So first, remember you want to determine based on the probability how many times do these firms expect to play this game. So you can kind of think of it just probability-wise. If there's a 5% chance, then the number of times they expect to play the game doesn't mean it's going to happen, but expected would be 1 divided by the probability of the game ending. So 1 divided by 5% or 1 divided by 0.05 would be 20. Okay, well, that'll make sense because 5% chance each game, and that gives us an expected number of times to play the game of 20. So given that probability, the game ends and there's no game consoles. It's a union strike. They can still expect to play the game 20 times. Okay, so 20 is the number of times that Atari and Nintendo can both say, okay, we're going to play this game over and over. Given the probabilities, I expect that I'll play this game 20 times. Okay, So what does that tell us about the outcome? Okay, so given the theta is 5%, the most likely number of times they'll play the game is 20. And you can see that this is the outcome if they cooperate, this is the outcome if someone cheats, and this is the outcome if they both cheat, and it goes back to Nash equilibrium. So this is how we do this one. So cheat. Okay, so if they cheat, the total number of rounds has to sum up to 20, right? Okay, so if they cheat one time, they'll get the 10. Okay, so once the agreement's over, it's over, and they go back to this one. So if one time they get the 10, there's the 10, there's still 19 more times they have to play the game. So one more time, 19 more times is the sum of 20. So is it worth it to cheat one time and get 10 and play it 19 more expected times and get 1? Okay, let's see how that works. So the number of times we play the game has to sum up to 20. So 1 plus 19 is 20. And the one time is cheating, and the other 19 times are back to the Nash equilibrium broken agreement. So 1 plus 10 plus 19 times 20 would give us an expected payout of cheating for both firms, essentially, of 10 plus 19, which is 29. All right, or what if they just play it 20 times and get this every time? Now you can see just by looking at it that's better. But if we think we're going to play the game 20 times, you can either confirm that 5 divided by the probability, or you can just see that playing it 20 times to expected to get 5 is going to give us 5 plus 5 plus 5 20 times, and that gives us an expectation of each firm cooperating, playing it 20 times and getting an expected 100 million. So it's clear that cheating just to get the 10 one time and then getting a bunch of ones isn't worth it, because if you can both keep the agreement, you get 5 every time, 20 times, and that's going to give us a much higher expected payout if both firms can do that. So Nintendo will cooperate. Nintendo will cooperate. Atari will cooperate because their expected payouts are higher. They'll stick to the agreement and price their game consoles at 200, and they'll both get an expected payout playing 20 times of 100 million. Okay. Lastly, we got a little description of the multi-stage or sequential game where someone goes first and someone goes second. So this one, finally assume these are Nintendo characters. Mario and Luigi face a multi-stage game where Mario is the leader and Luigi is the follower. Mario goes first and has to decide whether or not to marry Princess Peach. Okay, Princess Peach is the princess. If you ever, I don't know if anyone's ever played the original Mario Brothers. Actually, you probably have, but this is the when you beat Super Mario Brothers. This is the princess you find at the end of the end of the castle. So Mario has to decide whether or not to marry Princess Peach, and Mario has one decision who goes first. So Mario can either marry Princess Peach or don't marry Princess Peach. So Mario has one choice. Now, here's how the game goes. If Mario marries Princess Peach, Luigi has two choices. The first option for Luigi is to be Mario's best man, okay, in which case Mario earns 200 gold coins of happiness and Luigi earns 25 gold coins of happiness. The second option for Luigi is to steal Mario's gold, where Mario earns 150 and Luigi earns 75. So that's the portion of the game tree. If Mario marries Princess Peach, Luigi can do these two things. All right, then the second portion of the game tree is if Mario doesn't marry Princess Peach, Luigi again has two choices. The first option is for Luigi to sign up Mario for online dating, in which case Mario earns 100 and Luigi earns 25. The second option for Luigi is to steal Mario's gold, where Mario earns 50 and Luigi earns 25. So Mario has two choices who goes first. Luigi has two different choices based on what Mario might do. Okay, so draw the game tree. So Mario goes first. Marry Princess Peach. Don't marry Princess Peach. If Mario marries Princess Peach, Luigi has two choices: Mario's best man and steal Mario's gold. If Mario doesn't marry Princess Peach, Luigi has two choices: get Mario signed up for online dating, or again steal Mario's gold. And the outcomes were described. Uh, marry Princess Peach, be Mario's best man, and that's 20-25. Marry Princess Peach, steal Mario's gold, where that's the outcomes are 150 and 75, where Mario goes first. Or don't marry Princess Peach, where Luigi sets Mario up for online dating, and that's 100 to Mario and 25 to Luigi. And finally, don't marry Princess Peach, steal his gold anyways, in which Mario earns 50 and Luigi earns 75. So here's how this one goes. Uh, Mario is going to base his decision, just in terms of gold coins of happiness, based on the expectation that Luigi is going to act second in Luigi's best interest, because Luigi gets to go second. So Mario knows that if Luigi gets to go here, if he marries Princess Peach, Luigi can either be Mario's best man and earn 25, or steal his gold and get 75. So Mario knows, unfortunately, that if he marries Princess Peach, Luigi's gonna, you know, steal his gold because he's gonna make 75 versus 25. Or Mario knows that if he doesn't marry Princess Peach, Luigi's gonna compare these options: sign Mario up for online dating, 25, or steal Mario's gold. Unfortunately, it's too incentivized for Luigi both times, and he's gonna make his best choice. Okay. Either way, if he steals the gold here, it's 75 is better than 25. If he steals the gold here, 75 is better than 25. So what Mario is determined that regardless of what he does, Luigi is going to steal his gold. So that means that Mario is going to he can marry Princess Peach, Luigi steals his gold, in which case he earns 150, or he can not marry Princess Peach, Luigi steals his gold, in which case Mario only earns 50. So clearly, even though it's unfortunate that Luigi, doesn't be his best man, doesn't give a speech, he steals his gold. He's still much more happy marrying Princess Peach because 150 is bigger than 50. So you can see the outcome where both things are underlined in this area here, yellow, and the subgame perfect Nash equilibrium essentially is part F. You can describe it as both players' best uh, choices. So Mario will marry Princess Peach. Luigi will always steal Mario's gold, and the outcome will be marry Princess Peach, steal Mario's gold, in which case Mario receives 150 gold coins of happiness, and Luigi gets 75. Okay, so this one, similar to what most of you did for the chapter 10 homework, where you do a draw the game, the payout matrix. You do a one-time game, define the Nash equilibrium, then see if they can make an agreement, in which case, based on some probability of the game ending, is it worth it to cooperate and play the game a number of times or cheat? Is the one-time cheating worth it based on the number of times you expect to play the game? And then there's some third scenario where there's a multi-stage game. One of the players goes first, one of the firm's players goes second, and yeah. Okay. Questions on this this one here? Okay, so everyone feels good on all three questions, all aspects of the final here. Yeah. Okay, so there's under final exam summer 2021. There's the practice final we just went through, and there's my solutions both in the Excel file, and you're welcome to look at um, the stuff I did in Excel if you want to use that for a template for the payoff matrices and or the game tree, or you can do this on a piece of paper or graphing paper. Whatever you like to do for this one is fine with me. Okay, then here is your final. There's a Word version or a PDF version. They're both the same thing. If you want to use the PDF version and kind of do it on a separate piece of paper, you can do that. Or if you want to use the Word document and kind of write your answers internal into the document, you can do that as well. You got both options, but let me just the PDF is a little bit easier to here. Oops. Okay, so here is your final assignment, your final take home. So final exam, summer 2021, you're going to show all your work. Um, okay, this exam is worth 100 points, so it's worth the same amount as the midterm. And if you could put your answer sheet in a PDF or Word document, that would be easier for me to grade it. Either one of those is perfectly fine. And if you can submit your answer sheet to me by email, like it says in the syllabus, by this Thursday, it shouldn't take you too long, but I'd like to get them all by this Thursday, August 12th, and that way I can have your grades done and finished by the end of the week. So assuming I get all those um, exams and all your other finished assignments by Thursday, this Thursday, August 12th, um, I'll I should be able to have your grades all graded and done, exams all graded and final grades done by the end of Friday. Okay. So hopefully that goes to plan. Everyone gets their exam emailed to me by Thursday. And if so, I'll send you guys an email and say like your grades are done, your final grades are ready, and so on. But it all depends on if I get everything on time. So please try to give me your finals by this Thursday, August 12th, and that'll make me able to get your grades in by the end of the week. Okay. Here's the exam. So you got one on the profit maximizing choices. So you have one scenario, two scenarios, three scenarios, and you got to do the uh, profit max. You got to find the best quantity, the best price, determine if the firms should keep producing, what's their profit or losses, and then what type of firms are these? Okay, three of them there. Number two, you're going to get another Korno-Stackelberg scenario where you get a demand function, a cost function, a universal demand function, and universal cost functions, and then do the analysis first under Korno, find quantity profits for firm one and firm two and the market price, and repeat the analysis where you have a leader under Stackelberg, where firm one is the leader, firm two is the follower, and find firm one's quantity and profit, firm two's quantity and profit, and the market price, and then just compare them. Which one has the highest profit, lowest profit, and which market yields the lowest price? Okay, and then I have a game theory one where this is more. I did some shoe companies, and so they are technically I'd say the shoe companies are monopolistic competition, but you can do game theory for that too. So you got a Vans and Converse um, monopolistic competition where they're competing. This is an advertising game, so read the little description. Do the one-time game. You have a game with an uncertain final period, so determine if it's worth it to make an agreement. And then you have a multi-stage game where I believe Vans goes first and Converse goes second, and so read that outcome and kind of do those ones. Okay, so again, do by email, PDF or Word document, and the due date for this final is this Thursday, okay, not next Monday, this Thursday, August 12th. Questions on what you need to do for the take-home final? Everyone good on this? Okay, so again, your final exam is right here. It's on Blackboard. Final exam, summer 2021. Don't This one is the practice section. We went through that, so make sure you do this one. Final exam, summer 2021. So both of these two are the same thing. This is the one you got to do an email to me. Okay, so we're good on that. All right, so make sure you get that to me by Thursday, and you can email me with any questions. But I think most students should do perfectly fine on these. You've had a lot of practice here. Okay, and then lastly, um, so a few more of these. So everyone, the oligopoly homework is due today. So everyone's good on that. Do we need any more um, help on those? So make sure, because some students were not here on last Monday when we went through the whole oligopoly example. So make sure you have a confirmed topic. I think all of you do, and make sure you know how to do the analysis. And if you weren't here um, last Monday, you can watch the video on YouTube, or you can email me with assistance on that. But remember, this is everybody chose their own topic for the oligopoly homework, and that's just post your finished homework here, which is due today. Okay. So we've pretty much done everything I want us to do, which is credit to all of you. So we've got, yeah. So this is due today on Blackboard. Your take-home final again is due by email this Thursday, and that's going to complete all your assignments. And make sure you get everything into me by that time, and I should have your grades hopefully done by the end of the week. And yeah. Okay. So anything else, everyone? Okay. So I think so. This is our last meeting. So I think that's it. We covered everything I wanted to cover, and I hopefully you all learned something and liked the class. But thank you all for participating the whole summer, and I think that's it. So thank you all so much, and I'll look forward to seeing your finals.
Hi, Professor.
Yes.
This is Lina. I have one question.
Yeah. Sure.
Yeah, for our oligops homework. So, actually, for the discourse part, you said it's not have the fixed fixed answer. So, does this one have point or not?
Oh, for this. So this one.
Yeah.
Okay. So let me pull up. I think.
Yeah. So for the section 3, the discussion.
This one.
Yeah, so you mentioned before there has no fixed answer for this question. So does this one have point or not?
No, it doesn't really have. I mean, it just as long as you do the whole as long as you do the whole assignment, you'll get full credit. So as
Oh,
long as you do the data and do the forecast and just answer the question, so there's no yeah. As long as you do the discussion, there's no points. I'm not going to take out points based on what you write, but as long as you do it, you'll get full credit.
oh yeah. So as long as I did the discussion, I can get the full credit, right?
Yeah, of course.
Oh yes, thank you.
All right.
Also, I'm so worried about for the section one and section two. Uh, so if I answer was wrong, can I just prove your um like Excel or something that I can get more credit?
Yeah. So it won't be wrong unless you did the. You mean like the Excel part?
Oh yeah.
Um, yeah. If you want, you can post your Excel file. That's what you're
Oh,
asking.
oh yes.
Yeah, and I can double check it, but I mean, assuming you did the analysis,
Mm-hmm.
your your I mean your numbers shouldn't be they can't be wrong because it's just based on how you did the equation.
Oh yeah.
Uh,
I just a little bit worried about that.
okay, yeah, so I wouldn't worry about it, but if you are, you can post your Excel file and I can look at it, and if there are any problems, I'll let you know.
Oh yeah, sure. So actually, you know, so for some reason, like uh our in our room the internet is not good, so maybe I will submit my homework maybe 1 or 2 hours later. Is that okay?
Yeah, yeah, of course.
Oh yes, thank you.
Okay.
Thank you. I have no question.
Okay.
Sorry.
Yeah. Oh, that's it.
Uh-huh, yeah, that's it. Thank you.
Okay, you're welcome.
Hi, Professor. I have a question.
Yeah, yeah, please.
Yeah. When we submit our the final exam,
Oh, so you're gonna email it to me.
okay, when? What's the due date?
So the due date is this Thursday, and I think it says here on the. So if you when you go to the final,
Yeah, yeah, right. I know.
yeah. So here's the due date, Thursday, August
Okay,
30th,
okay, okay,
and then just yeah. So it's due
okay,
this Thursday, and you're just gonna email it to me.
okay. I know. Thank you, Professor.
No problem. Thank you.
Okay, bye.
Bye.
The professor.
Yes. Yeah. Go ahead.
Yeah, I just want to say thank you. Thank you
Oh,
for
you're
your.
oh you're welcome. Thank you.
Thank you. Bye bye.
Okay.